Today I would like to discuss the mix design because many of you are going to cast recently, or maybe a few of you will do in future. So today I will discuss the mix design. So in case of mix design, there are several mix design you can follow, but most popular one is the ACI, and you can also follow the UK, that is British standard we call it, and you can also follow the IS, Indian standard. So today I would like to discuss about the ACI standard. So this standard is ACI 211.1 91 corrections. Okay. So I don't want to discuss the basic informations like the concrete. Why do you need to adjust the water cement ratio? What is the how can you improve the durability and basic properties of concrete? I'm not going to discuss today because you already know, you are graduate almost. But you have some lackings on the mixed design portion, so that's why I'm just going to cover the mixed design portion. Okay, so just to give
Yes, sir.
a little bit more idea about the admixtures, chemical admixtures, there are different admixtures you can add. So these admixtures you can add as a cementitious material sometimes, if it is replacement of cement, or if it is adding you water quantity or water volume, that time you can replace the water quantity. So this kind of process you will see today. Okay.
Yes, sir.
Okay, so in case of chemical admixtures, you will find there are several uh, admixtures are there available in market. So based on their property or the effects, usually they name their admixtures name, like which reduce the quantity of water, that one we call water reducer, which delay the setting we call it retarding, which faster the setting we call it accelerating. So these way we name the different kinds of admixtures. So our main target is not these today, so we'll directly go to the uh, process. Okay, so there are 9 steps to complete the mix design. Okay, so first of all, choose of slump below. Okay, so you can select the slump below. So how can you select the slump below? You know the type of construction and workability you need for the particular project. Are you getting my point? You know where are you going to use your construction materials or concrete, or where you will pour this concrete. You need high slump or you need low slump, or what kind of workability of concrete you need. So based on that category you can select slump below. Okay, once you select the slump below, then you can select the, you already know based on your maximum based on your available materials. Usually in our country what we do, we find the materials are available, then we find the maximum size of the aggregate. Especially for the coarse aggregate, we try to calculate the maximum size of the aggregate. Okay, then once you know this, it will help us to decide the quantity of water, okay, and the quantity of the fine aggregate as well. And then we can estimate the mixing water and air content. So then we'll decide. So if I go one by one, if you consider the slump value, so have a look, you'll find there are some types of buildings that usually follow some slump value, right? Suppose just for an example, you're going to cast for a building beam or reinforced wall or column, whatever it is, normal, right? Normal situation. So that time we can consider maximum slump is 100, minimum maybe 25. This is in millimeter, right? So usually we select like that, or you can also select, okay, my slump below I want 75 to 100. It's up to you based on your requirement, but this is just not a standard guideline, you can follow this, but being a designer you can change it. Are you getting my voice?
Yes, sir.
Okay,
Yes, sir.
But keep in mind, if you are designing some concrete where you are considering consolidation or self consolidation, no vibrator will be used there. So you can increase usually 25 mm on this range. Okay, like where you cannot use your vibrator, you decide that is the self consolidation or consolidated concrete on that case. If you face any trouble, you can ask me. Okay, if you do not understand any term. Okay, so once you decide the slump below, then you can decide the maximum size of aggregate. As I said, usually we'll decide from the available size of aggregate you have. Okay, maybe you can see here. Can you see this? You have to zoom your screen even. Can you see it now? So I don't have the latest content of this ACI, so that's why I'm using my master selection note. Okay, so here you can see based on the slump value, okay, and based on the maximum aggregate size, okay, they are selecting the water. Okay, so they are considering the water amount. Okay, hello. So water kg per meter cube. So how much kg of water you need based on this size of aggregate and based on the slump value they consider. So they consider two situations. One is non-air entered concrete, another is the air entered concrete. Okay. Okay. If you consider the air amount, air in the concrete that time, if you consider, if you will enter, if you want to enter some air in the concrete, like you want to make some void on that case. Okay, so then once you get the maximum size by the help of slump value and the maximum size of aggregate, you can decide the amount of water and air content. Okay, if you consider non-air content, but definitely there will be some minimum air content also, so that is also you need to consider. Okay, then selection of water cement or water cementitious materials. Why do they name it differently? One is water cement, maybe you are using water and cement only, or sometimes you may use some cementitious materials like fly ash you can also use instead of cement, or maybe other chemical you are using in powder you are using as a cementitious materials. So that time cement plus that materials will be together. Anyway, so once you have this situation, then you can select. Okay, here you can see the water cement ratio. Okay, suppose this is the amount of strength in megapascal, so which strength you are going to design, you can think of it and then you can decide. So it is non-air entrained or air entrained one, so based on that you can decide, and there are some short notes you can read it as well, but for preliminary case you just try to follow this instruction. Okay,
Sir,
so
how can we determine that what type of concrete, what grade concrete we will going to work, 40 grade or 35 grade? How we can determine
it's
it?
up to you. You are going to be the designer, right? So
Yes, sir.
which grade of concrete you will select, it's up to you. Are you going to design your member for 25 megapascal or 30 megapascal, is up to you. You understand? Like who is going to tell you that okay, the concrete strength is 3000 megapascal, or not 3000 psi, or 3500 psi? You decide as a designer, right? Do you understand? Okay. Like if you consider like 25 megapascal, it would be nearly like 3500 psi, or just more than 3500 psi. Okay, if we consider 20 megapascal, okay, it would be like nearly your 3000 psi.
Okay, sir.
Okay, so you decide which strength you want
Okay, sir.
on 28 days. So then you can decide your
Okay,
water
sir.
cement. Okay. Okay, so then you can decide this one. So finally you need to calculate the cement content. Okay, then once you calculate the amount of cement, then you can calculate the coarse aggregate content. Okay, so you can calculate the coarse aggregate content. So coarse aggregate content you can decide this way. You know the FM value, right? You know the FM value. Okay, so based on the FM,
Yes, sir.
you know the maximum size of aggregate. Then you can get the volume percentage. Okay, so through this volume percentage or ratio, you can calculate that how much quantity of coarse aggregate volume needed for 1 unit meter cube of concrete volume. Do you understand? So once you can find it out, okay, once you can find it out, then you can also find the quantity of water in terms of 1 unit volume. Okay, you can also find out the quantity of air in terms of 1 meter cube volume. Okay, so you have water, you have air, you have coarse aggregate, right? You have cement, right? Also you have what? Fine aggregate. So if you consider 1 unit volume, so it should be 1 meter cube, right? So once you get all the volume, water, air, coarse aggregate, cement, so can you find this one? Do you understand? You just sum this value and reduce this value from this one. So that would be your required fine aggregate. So this way you can calculate the fine aggregate content also. So we'll do one example that will be more easy. Okay. So after that you will get a random suggestion of the, or random ratio, or a defined ratio I should say, based on this estimation. But here some of the factors you did not consider. What are these factors? Water content on the coarse aggregate and fine aggregate. Do you understand? Because if coarse aggregate is having some water, so it will affect the water content, right? Similarly for the fine aggregate also, if it is having additional water, you can reduce the required water. If you have what is called shortage of water, like if it is having some absorption percentage, it will absorb some water, so that time you can also add some water here. So you need to adjust. So that is called adjustment of the moisture content. Once you finish, then you can go for the trial and error. So you can go for trial and error, you can check your slump value. Okay, so once you can check your slump value and other values, if you find okay this batch is closely what you are looking for, close what you're looking for, you can consider this, or you can do some adjustment. Okay, so through trial and error you can come up to your final admixture. Okay, based on your available materials, that is important. If the materials properties and quantities are not different, we could have like consider only one design method or protocol. That time by using just simple formula we can decide the mixing ratio. But materials on different area or different locations depends based on the temperature, source of materials. So these things are vary based on different factors, right? That's why we need this kind of vigorous process for research oriented casting. Okay, so now if you do one example, okay, additional information is like that. Even though you have confirmed your water cement ratio here, right, but you need to check the exposure condition. Either it is in freezing or thawing condition, right? That time you can see the water cement content ratio should be 0.45 for this kind of members. Or others members it is 50%, 0.50. If it is exposed to the seawater or sulfate waters, do you understand? Or like some in industry where you have sulfate attacks, in concrete you have a high chance to have a sulfate attacks, so that time you have to consider these one around 40% or 0.4 or 0.45 for this. So this way you can adjust. Okay, since in our country, especially for Bangladesh, we don't have these freezing and thawing conditions. Apart from the sea belt like Chittagong and Cox's and some other area of the sea sides, we don't have this sea water content as well, right? So easily we just consider these one, except the emergency or exceptional case. So if I give one example, this one you can look into this example. Like concrete is required for a portion of a structure that will be below ground level in a locations. So the concrete will be in the underground where it will not be exposed to severe weathering or sulfate attack. So that means you don't have to consider this what I just discussed, right? Do you understand? You don't have to consider this extreme exposure condition, or sometimes we call severe exposure condition. Are you getting my point? Okay, so you don't have to consider this. Okay, so what are the other information is given? Structural considerations requires it to have an average 28-day. You can take note for the example, that would be easy for you to understand while you will look into the informations. I hope maybe you're taking note as well. So normally unit strength is how much? 24 megapascal. So at 28 days you need 24 megapascal. Okay, and slump value they are expecting if it is 75 to 100 mm, they are okay. Do you understand? So they have given you the informations, vital informations, and the coarse aggregate has a nominal maximum size of 37.5. It is also given. Can you see this? 37.5. So you have maximum coarse aggregate size is 37.5 mm. Always keep in mind the dimension. Okay, and dry roded mass of this is given. Usually this is the amount of 1 cubic meter for the aggregate actually. Okay, so volume of this 1 cubic meter is 1600. Okay, 1600 kg per meter cube. Do you understand? Hello, this is the 1 cubic meter volume of what? Your coarse aggregate. Yes. Okay, so now we can go for it. So first of all, so in the design step you can see we have to decide the slump value. So they have given how much? Now you should tell me. They have decided this is 75 to 100 mm. So step 1 is done. Okay, so now nominal maximum size of aggregate is also given 37.5, but for your case like whenever you will be doing the experiment in your laboratory, so what you need to do, you have to do the sieve analysis, you have to find out the nominal maximum size of aggregates, right? While you do the sieve analysis, you can pick the highest diameter of the specimen, and then you can do some by using the slide calipers, you can measure the diameter of this, and then you can do some averaging also there. Okay, then step 3, use non-air entrained concrete since the structure is not exposed to severe weathering. Okay, so usually we consider this is non-air entrained. Okay, so now we need to calculate the water. Okay, so they consider this is 181 kg per meter cube. Now check how did they check it, or how did they find it. Okay, here we can find it. Okay, so first of all, since it is not in the extreme condition, we will consider not or non-air entrained concrete. Okay, okay, so this is the first one we'll select. Then we'll select the maximum diameter of the coarse aggregate. How much? 37.5. You remember that? Okay, so for 37.5, this is the chart actually. Okay, so what is the slump value? 75 to 100. That is the range they were talking about, right? Okay. Okay, so have a look. If it is 75 to 100, usually the water is kg per meter cube is how much? 181, right? Okay, so approximate amount of entrapped air in non-air entrained concrete percentage, they have given nothing here, right? No information is given, but this chart was revised later on. I'll show you this one according to the code. Okay, here you can see this chart was revised later on, that it is minimum 1% actually. Okay, yes, sir. It should be minimum 1%, so they consider 1%. Okay, so we consider, okay, we'll consider 1% air. Okay, now here you can see they consider 181 kg per meter cube and air content is 1%. Up to this is clear? Step 3.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so now
Sir, I was disconnected, sir. Just mixing water, sir. Can you repeat again, sir?
there you can see this is 75 to 100. Okay,
Yes, sir.
so 37.5 is the maximum aggregate size. Okay, so if it is
Yes, sir.
aggregate size is maximum is this one, so for this one this is the chart. So second row you can see 181 is the amount of water in terms of volume, water kg per meter cube. Up to this clear? So
Yes.
so you still don't understand the 1%, right? Do you,
No, sir.
do you understand the 1% situation I discuss here? So usually these one is revised in another chart where you can see on that range. Okay, 1.5 inches is the maximum size range. They consider 1% entrapped air. Okay.
Okay, sir.
So that's why we consider this portion. Where it is? Okay, this portion 1% is air. So now it is understandable that how do you consider the amount
Yes,
of
sir.
water?
Yes, sir. Now it's okay.
Okay. So then we can finally calculate the amount of ratio. We just consider the water content, but yet we don't get any idea about the cement, right? We do not get any idea that how much cement we can use for this kind of strength. So okay, come up here. Okay, so on 28th day we need 24 megapascal. What is our expected value? 20.
So 25 megapixel.
I think expected one is 24. You do
So in
not take the
question is
note, right?
24, sir.
Yes, sir. 24, sir.
24, right? So
Yes, sir.
here the informations are given for 30 and 25, but no information is given for 24. So what you can do? You can do the interpolation, right? You can do the interpolation. So by doing the interpolation, you can calculate what is the water cement ratio for these. Do you understand?
Yes, sir.
Because for
Sir,
20,
someone of it is trying to connect.
no,
He's
nobody's
feeling
sending me any
aggressive.
request.
Okay, sir. Okay, sir. Continue, sir.
Okay, I do not get any request. So now have a look. 24 megapascal. For 24 megapascal, you need to calculate the what? Water cement content. So then you can do the interpolations. By that you can. So keep in mind you are using non-air entrained concrete.
Yes, sir.
Okay. So by doing the interpolations, they found this is 0.62. For 25, it is 0.61. Okay. So by doing the interpolation, they calculate water cement ratio is 0.62. Up to this is
Yes, sir.
clear?
Yes, sir. Yes.
Okay. Now, interestingly, you know the ratio of water cement, right? You know the ratio of water
Yes, sir.
cement is 0.62.
And I also know the sir water content.
And you also know the value of water. So
Yes,
can
sir.
you calculate the cement?
Yes, sir.
Are you getting my concept?
Yes, sir.
So you
Yes,
can
sir.
calculate the
Yes, sir.
cement. So how much they calculated? 292 kg per meter cube. So you calculate the water, you calculate the cement till now. So that is you calculated for 1 cubic meter.
Yes, sir.
Okay.
Yes, sir.
Okay. Now you can estimate the coarse aggregate content. So you can look into the what? You can look into the table where you can find out the coarse aggregate content unit. So here they did not did they mention any FM value in the problem?
Sorry, sir.
No,
They
sir.
did not mention any FM value, right? They supposed
Yes, sir.
to maintain the FM value
1.6.
of coarse aggregate, right?
Yes, sir.
So they didn't maintain or mention. Okay. Suppose this is 2.8.
Okay, sir.
Okay. So here you can see this is your maximum size, right? This is your
Yes, sir.
maximum size of aggregate.
Yes, sir.
Okay. Can you see right now?
Yes, sir.
Okay.
Yes.
So if they said FM value is 2.8, so this is the column you have to select, and this is the amount of what? Unit ratio of the coarse aggregate.
Yes,
So that
sir.
means what?
Yes,
In
sir.
1 cubic meter of coarse
Concrete.
concrete, you have to use 0.1 amount or unit of
0.7.
coarse aggregate. Do you understand?
Okay, sir.
So in case of percentage, is 71% of total.
Yes, sir.
Okay. So once you have this, so they consider 0.71 meter cube of coarse aggregate on a dry roaded basis. So this is the volume, not per unit. Keep in mind, This is the exact volume for per meter cube. Okay.
1 cubic meter concrete.
Okay.
Okay, sir.
So you know the unit weight, which is 1600 kg per meter cube. Do you understand? So if you
Yes, sir.
multiply this 0.71, so you are going to get something in kg. So exactly you get the mass. How much coarse aggregate you need it. Do you understand?
Yes, sir.
So this
Yes, sir.
much coarse aggregate you need. So 1136 kg. Up to this is
Okay,
clear?
sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So have a look. Here you calculated the water, then you calculate the cement. Now you calculate the coarse aggregate. So you still need to calculate the fine aggregate, right? So as I said, to calculate the fine
Yes, sir.
aggregate, what you need? If you know the water, air, coarse aggregate, cement, then you can reduce this total volume from the 1
From the
meter
volume
cube
of
volume.
concrete. Yes, sir.
So whatever the volume left over, that would be your fine aggregate. So that's why
Fine.
you need to calculate your air content as well. So to calculate the fine aggregate amount, so you calculate the water content. You know this is would be 0.181, right? Do you understand? In meter cube. This is
Yes,
in
sir.
kg. This is in kg.
Yes, sir.
181,
Yes. Yes, sir. It is.
right?
Okay, sir.
But if you want to convert
Yes,
into
sir.
per meter cube, you can divide it by 1000, because
1000.
1000 kg equals to 1 meter cube, right?
Yes, sir.
Okay. So then you converted it this way. And solid volume of cement. So in case of cement, you need to divide by this, but specific gravity of cement is not 1. Specific gravity of water is 1. That's why you can simply divide it by 1000. Do you understand what I'm talking?
Yes, sir. Understand, sir.
Okay. So for cement, specific
Yes,
gravity
sir.
is, usual specific gravity is 3.15. So you see, to do a proper mix design, so many informations you need to come up with, right? It's not like that simply
Yes, sir.
casting 1:2, 1.5:3. Okay, so this is the specific gravity. If you know, you can multiply with this 1000 and you can get the amount of cement you need in per meter cube, or in case of 1 unit of meter cube. Okay,
Yes, sir.
so this is
Okay,
the
sir.
meter cube quantity for the water. This is for cement. Now you need to convert this into for coarse
KG.
aggregate also. Okay.
Okay, sir. Okay, sir. Okay, sir.
Okay. So in case of coarse aggregate, solid volume of coarse aggregate is this much. You already calculate the volume of solid aggregate. Okay,
Yes,
coarse
sir.
aggregate. So this one, usually
Divided by
specific gravity of
specific
coarse
gravity.
aggregate we consider 2.68.
Yeah. Yes.
Okay, since you do not have the data, you can consider the standard one. It will not vary that much. Okay, it will be nearly
Yes, sir.
like that. So
So yes,
2.68,
sir.
some people consider 2.7, so it's also okay. So
So
you
we
get,
got 2.64.
yeah, you got new
2.64.
2.64.
64.
Okay, that means your
Yes, sir.
specific gravity test is almost okay.
Yes, sir.
Okay, so now you can see the volume of what coarse aggregate you found.
Posted.
Okay, for per meter cube, how much volume of coarse aggregate you found? Okay,
0.424.
okay.
Yes, sir.
Now we can see volume of entrapped air. So that is 1% only. So simply you just consider these one, these 0.01, that is the percentile, amount in case of air, and this is actually you can multiply with this value 1 actually, because it does not have any conditions. It may 1 volume or this how much volume you consider doesn't matter, right, in terms of air. Okay, so they consider the same amount of what volume. This is 1%, right? 0.010. Okay, then total you can see that this one is your water, this one is your water, right? Water, this one is your cement, right? This one is your
Yes, sir. And
coarse aggregate,
course aggregate.
right? And this
This
one
one,
is your
yes, sir.
air,
Air and yes, sir.
right? So if you take the summation of all these, you get this one. So how much left over?
Okay,
That
sir.
is your fine aggregate,
Yes, sir.
right? How much left over?
Yes, sir.
That will be your fine aggregate. So I will.
Finally,
So you know, in terms of 1 meter cube, okay, 1 meter cube. So that time you just reduce this volume, and you get the in 1 meter cube how much fine aggregate you need to add. Okay,
yes, sir.
so you get the unit weight, then you can calculate the uh, actual mass of this one, right? Do you understand? So to calculate the volume, you divide it by the specific gravity and the
Sir,
1000, right?
specific gravity on 1000. Does it
So you divide
means
it,
the mass
but
density?
to convert just opposite way, volume to kg or volume to mass, you just multiply the specific gravity and the 1000.
1000.
You understand? Why do you consider
Yes, sir.
1000 and specific gravity? I hope you
Sir,
understand,
this is
because if you consider
it
the
refers
water
mass density.
volume in 1 meter cube, it would be 1000 liter or 1000 kg, right? And the specific
Okay, sir.
gravity of water is 1. So with respect to specific gravity of water, how much is the specific gravity of individual materials, we are just multiplying with that, and this is the way you can find out the weight. We are not converting into volume, we are converting to the weight.
kg.
Okay,
Yes, sir.
okay, so then you can also calculate the amount of fine aggregate. Finally you come up a ratio, you come up in a one solution where you need 181 kg of water, 292 kg of cement, 1136 kg of coarse aggregate, and sand is 771 kg. This is the situation you have. Okay,
Yes, sir.
so do you know how to find out the ratio? From here, first of all, you can find out the water cement ratio, right? So what is the volume of water and cement? So you'll get it the ratio you
Yes, sir.
consider, right? And you can find out the
Okay, sir.
ratio, mixing ratio. So how do you calculate this mixing ratio? Suppose 1 is to 2 is to 4. What does it mean? What does it mean by 1?
So one is cement, two
Hmm.
is fine aggregate, and four is coarse aggregate.
Okay. So cement, fine aggregate, coarse aggregate.
And coarse aggregate.
So for this
Yes,
one, can you find out this kind of ratio? For that, what you need to do? You need to divide by the cement volume. Sorry, cement weight,
yes, sir.
right?
Total. Yes, sir.
Sir,
Yes, sir.
sir, if we take cement as a one, like unit, that time we can find out another one.
Yes, so you just simply divide by the amount of cement, every quantity. Like
Yes, sir.
292
Yes,
divided by 292, you'll get the cement one. Coarse aggregate,
okay, sir.
sorry, fine aggregate, 771 divided by
71 divided
292.
by
How much?
292. Yes, sir.
Divided by
How much
2.
it is?
Sir, calculate this.
2 points. So you're not prepared.
2.6%.
Sir, course aggregate is, sir, 3.89.
I just asked for the fine aggregate.
Sir,
Fine aggregate
Sir, that is 2.64. 2.64.
2.64.
sir, 2.64.
2.6
Sir, 2.64. Fine
Okay,
aggregate.
2.64. And this one
Sir, 3.89.
3.89.
3.89.
So this is the initial ratio you found. Yet you did not adjust the moisture content or absorption value.
Yes, sir.
Do you understand? So once you consider the
Yes, sir.
moisture content and absorption value, so that time you will have a new mixing ratio of concrete. That would be your appropriate one. Okay. So now
Yes,
if
yes, sir.
you just adjust,
Right.
okay, suppose had they considered the adjustment like this way, that coarse aggregate is wet. Okay, that means what? They have more water. Okay,
Yes, sir.
so they have 2% of water. What does it mean? 2% of moisture content.
Yes, sir.
So what was the amount of coarse aggregate we calculated? 1136 kg.
36. Yes, sir.
Hmm?
Yes, sir.
So to keep dry unit of 1136 kg of coarse aggregate, on the aggregate you have 2% moisture content, you need how much? 1159
59
kg
kg.
of what? Coarse aggregate. Do you
Course
understand
aggregate,
this
sir.
one?
Yes, sir. Here we consider 2% moisture
Yes,
content, sir.
2%,
Yes, sir.
1 plus 0.02. Okay, so this
Yes, sir.
one multiply
Yes,
with
sir.
1136 and also additional this one, because this weight is
2%.
actually weight of water, not the aggregate. So if you consider the same amount of aggregate, that means you are considering, can you tell me 2% of 1136? How much? 4, 23, right? 25.
22.72.
22.72.
7,
22.72.
23, approximately 23 kg of aggregate. If you do not consider the moisture content, 23 kg of aggregate will use less. Do you understand?
Yes, sir.
Yes, sir.
And if you consider this 2% of moisture content on this one, 23 liter of water you are going to add. Are you getting the threat? What would be
Yes,
the
sir. Yes, sir.
situation?
Yes.
Okay. Similarly, for
So
the
water content will
water content, you see, water content increase. And fine
yes,
aggregate,
sir.
they say again this is the weight, that is the moisture content is 6%.
6%.
So similarly, you consider. So you can see that almost 29 and 46 kg, right? 46 kg of aggregate need to add for 6% of water content. So if you do not add this one, okay, so that means you are going to add 46 kg less fine aggregate, and you are going to use 46 kg of water, more water.
Yes, sir.
Okay, so now absorbed water does not become part of the mixing water. So in case of, they do not consider the absorption rate here, but if materials absorption rate is also given and materials is not fully SSD, that time you need to also consider the absorption rate. But they consider materials is having extra water, which is moisture content. Okay.
Yes, sir.
So finally, you get a new amount of coarse aggregate. How much? 1159
And final aggregate
and 817.
870 kg.
Okay. Now, amount of water is here. You need to adjust on the actual volume of water, right?
Yes, sir.
Do you understand?
Sir, can you repeat, sir? This is not clear to me.
This much amount of water, you get it because it is wet. 2% water is
Yes,
there,
sir. Yes, sir.
right? This is wet. 6% water is there in fine aggregate.
Yes, sir.
Okay. So you need to
Yes, sir.
cross check that either this coarse aggregate and fine aggregate have any absorption rate or not. If it
Okay, sir.
absorbs, so you can reduce this water absorption from this quantity also. Because wet means what? It is going to add your water quantity. If it is absorbed, it is going to consume water quantity.
Okay, sir. Okay, sir.
For wet condition, you will reduce the water from your original water. For
Yes, sir.
absorb condition, you will add water to your original quantity of water.
Yes, sir.
Okay, so they
Got
just
it, sir.
give some random absorb water uh, condition. Absorb water does not become part of the mixing water, right? Because it will absorb. So that's why you have to reduce this absorb.
Okay.
So for the coarse
Okay.
aggregate, they have 0.5% of absorption rate. How much? Very low. It absorbs 0.5%, but it gives
Yes, sir.
2%. It will give 2%. It will consume
Absorb
0.5%.
0.5%. Yes, sir.
Do you understand? So what is the balance?
Yes, sir. So
1.5%
1.5%.
it will give, it will add,
It will add. Okay.
right? So that's why they said
Yes,
surface
sir.
water contributed by the coarse aggregate. Contributed means what? Adding.
Adding. Yes, sir.
So how much percentage?
1.5%.
1.5% of what? Coarse aggregate.
Sir, of. Okay.
Keep in mind, these percentages are very sensitive. 1.5% of coarse aggregate.
Posted.
Which volume? This volume. This is your original volume. Okay?
Okay, sir.
Okay. Similarly, surface water
Okay.
contributed by the fine aggregate only
Yes, sir.
0.7%. It will absorb, but it will give 6%. Do you understand?
Yes, sir.
6% will give to the mixing, 0.7% will absorb.
Mixing.
So if you do the difference,
Absorb.
5.3% will contribute.
Contribute. Yes, sir.
Do you understand?
Yes, sir.
Similarly, if I say this easily for the coarse aggregate, this example true actually sometimes. If I say this coarse aggregate gives 2%, that is the weight is 2%, but absorption rate is 3%. That time you will get the value is minus 1%. So what does it mean? It reduce water volume,
It consuming 1%. Yes, sir.
right? So that time
1%.
original quantity you need to add more, right?
Add more. Yes,
So
sir.
since here you find positive, original quantity will be reduced.
Yes, sir.
Do you understand?
Yes, sir.
Okay. You might need like 1 hour revision to comprehend these examples again, but now there is no pressure of the course exam and class exams, right? So hopefully you'll understand
Yes,
it
sir.
more, because I find like students understand more whenever they do not have any pressure, whenever they have the pressure to learn just. Anyway, let's see how much you
Yes.
can understand. So now have a look. Your original water quantity was 181 kg or liter, whatever you like to say.
181 kg, sir.
Yes,
Liter kg.
181
Okay,
kg.
sir.
Okay, so then this value of water, like 1.5% water, it
Of
will add to your
coarse
concrete,
aggregate.
right?
Yes, sir.
This much water you will get from the coarse aggregate, and another percentage of water you will get the fine aggregate. So you already have some water, suppose.
Yes, sir.
So you already have some water from where? From coarse aggregate and fine aggregate. So
And fine
that's
aggregate.
why you are going to reduce this amount of water to maintain your strength. If you do so,
Yes,
what
sir.
will be the scenario? Your strength or expected strength maybe fall or maybe
Closer.
not up to date. So that's why you are reducing this
Okay,
amount
sir.
of water. So you are reducing
Yes.
1.5% from the coarse aggregate. So you can see how much volume, and you can reduce 5.3% from fine aggregate volume. Finally, you find that is 122 kg of water needed, right? So this percentile is not universal. You might ask questions, sir, how can you get this one? So that's why I think someone referred than Pfizer here, right? So that's why I told you to find out the moisture content, absorption capacity. So now if you do the mix design, it might give you the accurate result or more close result that you are designing your concrete, instead of just
Yes, sir.
simply mixing with a certain ratio.
Yes, sir.
Okay.
Yes, sir.
Okay, so now have a look. You are getting another ratio that is called this and this. So you find water is 122. So now you can calculate new water cement ratio. How much?
Adjustable.
Who can tell me?
Okay. Okay, sir.
122 divided by 292.
0.417.
0.41.
0.41. So keep in mind this
417.
is adjusted. This is not the accurate one. If your
Yes,
aggregate
sir.
condition is like that, if your coarse aggregate and fine aggregate condition is like that, that time you can use 0.41 if you are looking for 24 megapascal of strength.
Strength. Yes, sir.
Similarly, now you can look into the new coarse aggregate, that is weight, that is sand also weight, and this is the total. Now you can find out the new ratio. What? Cement, fine aggregate, and coarse aggregate. Because you decide this is for what? 1 meter cube, but your one or your design situation may not be for 1 meter cube. So that's why you might be looking for this ratio. So cement is 292 divided by 292, 1. Then
One.
fine aggregate is how much?
Sir, 2.79, sir.
2.2.79.
Sir, 2.9, sir. Yes, sir.
And coarse aggregate
3.97.
3.96.
3.96.
96.
Yes,
Yes,
sir.
sir.
96.97, sir.
Okay, whatever it is, similar.
3.97. Okay, sir.
You see, so now you get a new ratio based on your what? Available casting materials.
Yes, sir.
Okay, so later on you can just go for trial and error. So you can look into this one, but I'm not going to discuss any more because it would be more pressure for you. So you can look into this. I may share these slides to you.